Today, we're going to talk about something called Layermix. It's a really clever new way to tackle one of AI's oldest and most annoying problems, the fact that it can be, well, surprisingly fragile. We're going to see how this method helps make AI tougher, more reliable, and just plain ready for the real world. So, let's jump right in.
But before we get to the solution, we really need to understand the problem that Layermix was built to solve. It all comes down to this hidden weakness, a kind of surprising blind spot that you can find in even the most powerful AI systems out there.
So yeah, let's just ask that question. How smart is our smartest AI? I mean, on one hand, these things are incredibly powerful. They can do things that feel like magic. But on the other hand, they have this hidden brittleness, a weakness that can cause them to fail in some pretty shocking ways.
Look at this. Under perfect lab conditions, with a nice clean picture, a modern AI doesn't even break a sweat. It sees this image and yup, it knows it's a corgi. Exactly what you'd expect. Simple, right? But here is the massive catch. What happens when things aren't so perfect? You add just a tiny bit of visual noise, the kind of random distortion that happens all the time in the real world, like from a smudged camera lens or a glitchy video feed. And suddenly that super smart AI can get it completely, totally wrong. This is that fragility problem we're talking about. So to fix this, to get our AI ready for the messiness of actual reality, researchers have this really powerful tool in their toolbox called data augmentation. The best way to think about data augmentation is like a training montage for an AI. Like in the movies. Instead of just showing it the same perfect photo over and over again, you show it thousands of messed up versions. You blur them, you twist them, you change the colors. You basically rough it up to prepare the AI for anything the world might throw at it. And this is not just a small improvement. The power of this idea is kind of mind-blowing. Research has shown that a really smart data augmentation strategy can make an AI tougher than another model that was trained on 1,000 times more data. It's all about training smarter, not just bigger.
Now, this whole idea of mixing up the data to make AI tougher has been evolving for years. And over time, researchers have gotten more and more creative with how they do it.
You can really see a clear story here. The early methods were pretty simple, like just randomly erasing a chunk of the picture. But then came this big leap with techniques like mix-up, which started blending two different images together. That idea got pushed even further with Augmix, and then things got even weirder with PixMix and iPixMix, which started mixing images with these strange, complex patterns. And all of that leads us right to the next step in the evolution, Layermix. So what's the secret sauce here? What actually makes Layermix different from everything that came before? Let's pop the hood and take a look. Layermix really starts with two main ingredients. On one side, you've got your regular training image, like this picture of a bird. And on the other side, you have these incredibly detailed grayscale patterns called fractals. You can almost think of them as a kind of structured static, just full of all these intricate little shapes and textures. Okay, here's the first really big idea. The old methods were what the paper calls IID, which stands for independent and identically distributed. Just think of it like rolling a different set of dice for every single step of the process. It's totally random and chaotic. Layermix is much smarter. It picks one kind of transformation, like, say, a specific way of rotating the image, and it applies that same transformation consistently throughout its process. The paper calls this covariant. This makes the distortion much more structured, which actually teaches the AI to find patterns even inside the noise. This whole structured approach then gets plugged into a three-step pipeline. So step 1, the original image gets augmented. Step 2, that result gets blended with a differently augmented version of the same image. And then finally, step 3, that newly blended image gets mixed with one of those complex fractals. It's a very deliberate, layered process. And what you get at the end is this amazing variety of, well, almost dreamlike, surreal-looking images. By training on pictures that look like this, the AI learns to ignore all the distracting surface noise and instead focus on the basic shapes and features that really define an object. It learns what makes a corgi, no matter how weird the picture looks. Now, all of this sounds really cool in theory, right? But the real question is, does it actually work in practice? Well, the researchers put Layermix head-to-head against all the previous methods to find out. So the main test was pretty straightforward. They took an AI model and tested how well it could identify images that they had deliberately corrupted with all sorts of visual noise.
The score they use is called the mean corruption error, or MCE. All you need to remember is, for this score, lower is better.
And the results? Well, they really speak for themselves. On a tough dataset called CFAR 100, a standard model had an error score of 50. The previous best, a method called PixMix, got that number down to 35.5. But Layermix came in and scored just 30.3. That is a huge jump in performance.
But it wasn't just about handling corruptions. This chart shows that Layermix pretty much won across the board on multiple different safety tests. It had the lowest error, as we saw, it had the best prediction consistency, and it had the best calibration, which basically means that its confidence actually matched its accuracy. So if it said it was 99% sure about something, it was right 99% of the time. It's just a clean sweep.
So we've gone through a lot of technical details here. But why does any of this matter? Well, because building a more robust AI has some really big consequences for all of us. Yeah, this isn't just some academic thought experiment. A more robust AI means we get more reliable medical diagnoses from things like CT scans, even if the image quality isn't perfect. It means we get safer self-driving cars that can see properly in the rain or fog. It means AI assistants that don't get thrown off by a simple change in how you phrase a question. At the end of the day, it's about building AI that we can actually trust when the stakes are high. New techniques like Layermix are a massive step forward in making our AI systems more resilient and dependable. But it also leaves us with this big, lingering question for the future. We're definitely making AI more robust, but can we ever make it truly foolproof?